Next up, we've got Roberto Rodriguez, a security researcher at the Microsoft Security AI and Research Organization. And in this presentation, he will share his research on LLM-based AI agents. The title of his talk is The Rise of the Planet of the Agents, LLM-based AI agents and cloud security APIs. Please give Roberto a warm welcome.
Awesome. All right, thank you very much, everyone. I'll try to be as loud as I can so you guys can all hear all the way in the back. Nice. Okay, so today, the topic, right, the rise of the planet of the agents. So I hope that after this presentation, you can actually walk out of here with some tools, with some topics, I guess, or context around how to build your own agents. And I have found that they're actually super useful to automate a lot of stuff that usually might take a couple of scripts, a couple of workflows that you have to define. So why not using LLM-based applications in order to help us, right, define all those workflows for security? And this could be, of course, for offense and for defense, right? And before we start, I'm an AI cybersecurity enthusiast, and everything I say today, everything that I'm going to share is my own research, and it doesn't represent, right, Microsoft at all. I just want to make sure that's clear. So with that being said, let's start with the topics. Where first we're going to talk about some of the use cases that I see LLMs being used at the moment and some generative AI, all the way to start diving into what are agents, how Microsoft Security Graph APIs, it's a good use case to start thinking about how to use these applications, and at the end, how we can build a Microsoft Graph API LLM-based agent. So when we think about use cases, in the workplace, I see a lot of different people that are trying to summarize content, trying to provide additional context of scripts, trying to define some type of chatbots or conversational agents so that analysts can have this like guided response experience. And we also see people using LLMs to extract context from unstructured data and try to put it in a way so that it is easy to search or easy to get more context and even enhance your analysis, right? Think about like taking all the notes that you have in an incident response, or maybe as a red teamer, like you have a lot of different things that you want to do, and those are mapped to tools, so you can actually get a lot of context out of all of this unstructured data and be able to use LLMs to build that knowledge graph for you, right? And then at the end, the search and retrieval capabilities. A lot of companies are also trying to use the concept of retrieval augmented generation to take all these manuals, data, unstructured data too, notes, etc., so that it could be easy to search by just trying to find similar or relevant documents to your question. And we're going to talk about that in a little bit, but this is what I see a lot, like companies trying to do. And of course, today, the concept of workflows, right? How can we use agents and agentic workflows, which is something that it is actually, picking up right now. So the main concept in here is that we're trying to enhance these LLMs that we're working with. And what that means is that we're not only trying just to ask questions, right? We're trying to provide additional context based on our use cases, right? Based on our organization, our own teams, our own engagements, etc. And that's called knowledge enhanced LLMs. And in terms that you might have already heard, this is the concept of retrieval augmented generation. How you can expose an LLM to additional knowledge by pointing to some type of source knowledge and be able to enhance the conversation that you have with it. So think about that. If there is any private data, anything that only your company knows or your team knows, you are able to expose that LLM to that type of data so that you can ask questions and have that context as part of your question as well, so that you shape the answer in a better way. The basic flow of a RAG process is actually taking your documents, being able to split all that information in chunks, be able to generate embeddings, which means numerical representations of those documents, and then have them stored in a vector database, where then you can actually have some type of retriever process, where when you ask a question, your question then gets embedded, so it is transformed into a numerical representation, and then you can actually search for any similar documents in your database. Once you do that, then your question will have additional context, and then the LLM will be able to answer in a better way because it was able to have additional information that probably it was not trained with or it was not aware with, right? Think about LLMs have constraints, right? They only know about the data that they were trained with, and if their training data was up to 2023, then that's all they know. So they don't have context of like what's going on right now, right? So this is one basic technique to enhance the LLM knowledge. So the idea is to be able to now take this concept of RAG, for example, and that could be a tool. That could be something that you can use with other multiple tools for your own engagements. And the concept of agents is how can we expose this application to these different tools. Everything that has to do with data has to have an interface to communicate, right? So this is like the basic concept of saying, let's take all these workflows that we are defining to expose LLMs to more data, and let's pair it with an agent that it will be able to help us choose what tools to use depending on the question. So now we get into the concept of LLM-based autonomous agents, which the concept of an agent, think about as is anything that can act on its own. And when it comes to an AI agent, is an artificial intelligence. I guess it could be a script, it could be a model that is capable to reason, and it's going to use, in this case, tools to be able to expose itself to the world and be able to interact with the world and be able to validate their actions, etc. So an LLM-based agent, then, it's an AI agent that is using LLMs in order to help with the reasoning of like what's actually going on at the moment. If I want to execute an action, I can use the LLM to help me choose the right tool for the specific task, for example, right? And the idea is that LLMs are great at, since they understand the language very well, right? They understand actually feelings in text. So it is easier to say, can you think on step by step, for example, right? What can I do in here? Can you plan in natural language? And that's pretty much what we do. If you ask me how to do something at work, I would explain to you in natural language in specific steps. So LLMs have the same capability, and that's what agents, LLM-based agents, use in order to enhance its own autonomous system. So we are going beyond just your typical you interacting with a chatbot. Now we have an LLM that is going to capture the question, it's going to reason over the question, and if you expose this agent to tools, it will be able to choose the right tool once again to execute. And the reason why it does that is because we want to expose the LLM to the world, to the actual physical world, right? And then every time these tools get executed, then the observations, the results, are going to be passed to the LLM, and if there is more to do, it's going to continue going through this iterative process. Okay? That's the basic idea of an LLM-based AI agent. So as I mentioned before, a reasoning engine is pretty much trying to think in natural language logically based on the problem, and this is of course not 100% bulletproof. It actually has some, it is very fragile, but it could help you if you scope your tools and the context, you could actually get some good responses from LLMs. So one of the first, I would say, techniques was something called chain of thought, which just by saying, can you, this is how I did a similar exercise, just by providing examples in the prompt, it is actually able to follow some type of process to be able to solve a problem. But right now, it's not being exposed to anything, right? It's just us telling an LLM, you can do this, this is how it was done before, maybe you can solve the same issue with this type of workflow already defined for you. So chain of thought was one of the first techniques. And reasoning is not enough. So what that means is we need to expose this to the world. So going to the next slide, there was this technique that came out in 2022, which is called REACT, which is reasoning and actions, or ACT. So when you reason and act, what that means is that you can actually pair some of these techniques to say, I want you to think step by step, but every time you want to take a step, I'm going to stop you right there. Tell me which tool you want me to execute, and I will do it for you. And once I execute it, I'm going to pass the results back to you. And that's how we continue the conversation. That's the basic concepts of React. And the idea is to follow this pattern of thought, action, and observation. Thought, you got to think about what it is that you need to do. Actions, it's what is available for you to take, and then I will execute it for you, and I will pass the observation back to you. And we continue this conversation. This is super interesting because this, of course, was not defined by the security community, but I'm actually trying to test how we can bring the ODA loops, right? ODA loops into this type of framework, because I think that it actually has a similar context than something that was created by, let's say, researchers or applied scientists in the world. So I hope that this now makes a little bit more sense when we say reasoning and actions and what techniques can be used to actually do this. Now, when we talk about tooling, execution of tools, there's a couple of ways that you can do it. One way is to actually using the concept of function calling from LLMs. And that's a way, for example, an example in here is from OpenAI. You can actually pass a function signature. So think about a Python function that you define. You can actually pass the name, the description, the doc strings, the type hints, the parameters, and you can actually have it as a specific JSON schema format that then you can pass to models like, for example, OpenAI GPT-4, right, GPT 3.5. You can actually pass that information, and that's the way how you are passing a tool to an LLM to choose or tell you how to use it. And the way how it works, if you've never done it before, is you define your prompt and you define the tools that you want to send to the LLM to help you choose depending on your question. So in this case, we're sending the message, we're sending tools. The LLM is replying back saying, for your question, you need to run the tool get weather, and these are the arguments that you need to pass, right? The parameters and the values. So remember, LLMs do not execute actions. They just tell you how to execute the actions based on your question and the type of tools that it has available. Once you execute the action, then you can pass the response back to the LLM. And the cool thing about function calling, especially from OpenAI, is that you can actually have, they provide an ID for the tool that is being suggested to you. So when you send it back, you're sending the response with the same tool ID. And if there is multiple tools to execute, then it knows that there is more now to execute. Thank you for executing this first tool. Let's move to the next one, right? And then at the end, the LLM will respond back with a more friendly, natural way to talk, right? Because when we execute tools, sometimes we are calling APIs, so the response might be a JSON object, or it might just be just a couple of words. So you still need the LLM to help you understand what it is that happened, so that it turns into like a more friendly conversation. And there are models like, once again, OpenAI models, Mistral, Gemini, and also Anthropic models. You can actually use a lot of these function calling capabilities. But of course, not every single LLM has that. So one technique is to actually pass the tools, the descriptions of the tools, and then pray, pray for the LLM to provide the arguments of your function and the name of your function in a structured way so that you could actually use it. So the difference with function calling is that function calling is managed by the LLM service, versus when you want to get some type of functions back to you so that you can execute them, it's going to be managed by you. And usually will be done through the prompt. And that's a little painful, but a lot of LLMs are getting better at actually outputting JSON. There is also people in the industry that are using YAML instead of JSON, and also XML, because it's easier, I guess, and it's more forgiving than actually having a JSON object that needs to be perfect JSON, right? All right, so now we move to now that we understand what LLM-based AI agents are, so hopefully this makes sense, is how do we expose the tools that we have to some type of system that is capable to reason over my question, and it's going to allow me to simply say, hey, which tool should I actually use for this specific use case, right? So that's the basic concept of using one LLM-based AI agent for an agentic approach. So, okay, I have 15 minutes. Okay, so now let's move to the multi-agent world, right? So we talked about that you can have one agent, you can have multiple tools, and you can use it to execute things for you, and it will reason over your tools. But let's be honest, a lot of the things that we do might require multiple tools, might require maybe different types of models. So one idea is to use multi-agents where you could actually specialize one agent for a specific task, and you can expose that agent for very scoped tooling. So think about if you have a SOC analyst or a threat intel analyst or just an RE analyst, they will have different tools, they might have different access. So think about as multi-agents as a way to define agents as microservices that could be exposed to a problem or multiple tasks, and they will be able to solve it either as a very deterministic workflow or as reasoning over all of them and trying to figure out who is supposed to be running the first task or the second task or the third task, right? That's the concept of multi-agents in here. And this takes us to the concept of agentic workflows. A workflow is a way to orchestrate tasks, and usually this might be super simple to you, but these concepts are actually new for the agentic world, where you need to execute a task. You might want to keep the state of the task. You might want to pass the output of one task to the next one. And that actually needs to be defined by multiple systems. For example, there is one that I'm using right now, which is called Dapper, which is Distributed Application Runtime. And it's something that you can use to orchestrate a lot of the different tasks that you can run in a specific engagement. So what does it mean? So usually when you have a workflow, like this is what it looks like. Now we're getting into Microsoft Graph APIs, right? If somebody says, can you create an app, add a secret, grant permissions, and then please authenticate as the app and then read mail, usually you will have to go through the API and figure out exactly how that's being done if, of course, you're using the Microsoft Graph API, right? So think about this is every single attack path or every single workflow that might work in your organization. You will have to do this exercise, and you might have to know the API very well, or you might be doing some debugging just to figure out what APIs are being called underneath when you're using either the portal or you're using another tool, right, that you want to just simply build a wrapper around it, right? The agentic workflow will look like something like this, where you don't have to know about the APIs. You just need to expose an agent that understands or has some type of access to the API specifications, and then you're able to ask the question to the agent just to make sure that they are capable to understand and answer your question. So in this case, if the user says, I want to do all these 3 tasks, an agent is supposed to be splitting the tasks and maybe calling the right agent to execute one thing at a time. And once again, you can make this very deterministic, or you can simply say, figure it out, right? And the way how this figure it out means is every single agent has a task and a description in natural language. So technically, the orchestrator will be able to read every single agent's purpose and goal, and also some of the tools that it has available, and be able to make a decision, what is the right agent that I need to execute, right? So I like this better because I don't have to think about the API as much, right? And there are a couple of agentic patterns that exist right now that are very simple and also very famous, but not so much in the security field. They're very famous in other fields where you could say, for example, I want to define a sequential workflow to write a paper, where the first task is maybe let's search something, let's read something, let's summarize something, and then let's write something, right? So you can do a lot of that, or come up with the best marketing strategy. Like you can do that with a workflow, right? But in security, I haven't seen so many workflows or agentic patterns being used yet. So you have the sequential, which is pretty deterministic, right? You really want to understand exactly how everything is going to be executed. And then you have the concept of a conversational group chat, which means that when the question or the prompt enters the agentic workflow, there is an orchestrator that will start communicating with the other agents once again, saying, hey, I want you to execute this, let me know what's going on. When something gets back, you can pass it to the other agent, and so on, and try to figure out how to actually solve the problem. There are tools that exist already in the community, such as AutoGen, and this is open source, and it's something that you can use and actually define these type of agentic patterns, right? So highly recommend to look into AutoGen and be able to see what makes sense for your use case. Something very simple, such as just, let's go to the next one. Something as simple as this, for example, where you have a sequential, right? Agent A is talking to all of them, which means that Agent A is the orchestrator having conversations with every single agent, and the output of one of the first tasks, right? The first task is gonna be passed to the next one, and the next one, and the next one. So think about right now, in your organization or in your own research area, what workflows exist, and how can you start automating a lot of this? Or how can you involve the agent in these workflows? Because you might say, why do I need an agent where I can just write my scripts in this way and that's all it takes? Well, there will be some nuances, like things that you cannot control sometimes, that might be helpful to have an LLM that will be able to understand that, oh, there is a problem, maybe this could be fixed by this other agent, or maybe this agent requires more context, more data, so let's probably execute other workflows or other tools. That's the value of having the LLM-based agents in this type of concept. And finally, the group chat, as I mentioned before, this is also from AutoGen, and you could see how agent B gets picked, gets the message, and then all the messages that were intercepted by B are actually being sent to the other ones as well. So it can broadcast exactly what's going on to the other ones, because remember, it is a conversation across LLM-based applications, right? Agents. So when we talk about Microsoft Graph API, we all know that it's the gateway to Microsoft 365 data, the gateway to a lot of different services, and we use it a lot for incidents, right? Because we can get context from alerts, we can get context from incidents, artifacts, etc. But at the same time, you get folks like GraphRunner, which are actually using, right, these APIs to craft specific workflows, very deterministic workflows. So if you go to the GitHub repo, you're going to see exactly how they chain multiple APIs, and that's awesome, right? Because it kind of helps us to maybe also test how our multi-agent framework can do and maybe discover the same type of workflows that exist in GraphRunner, we could actually have it without writing any type of code the same way how they have it, right? Because if you see in the code, it's like a very long script. If you have agents with the right APIs, you could actually be able to solve some of the modules that they already have available, right? So now let's dive into what does that mean from agent and Microsoft Graph API. The first idea was we have a prompt where we could actually get some of the Microsoft Graph Open API specifications. We can pass it in the prompt and say, hey, I'm trying to do X. Let's say, create a user. Then you will pass all the user, specification APIs, and you expect the LLM to tell you, this is the API, and these are the parameters and the values that you need to use in order to create the user. That was the basics. And then you can have the access tokens being part of the tooling, and simply the tool will communicate with the Microsoft Graph API. But that's not sustainable, right? Because if you look into the Microsoft Graph API, it's a very large, it's like hundreds and hundreds and hundreds of lines of specifications and definitions. And this is an example. If you go to this GitHub repo, you will be able to see most of the endpoints that exist for the Microsoft Graph API in its Open API specification, okay? Now, what you can do now instead, this is something that I'm doing right now, is maybe what I can do is I can use the concept of retrieval augmented generation and put all the hundreds and hundreds of definitions into a vector database, and then I can have a tool that says, hey, I want to create a user. We expect this RAG tool to go to the vector database and says, your question is very similar to these 5 APIs. So now we can retrieve 5 APIs from hundreds of APIs and be able to pass them to another tool that is going to execute those APIs, pretty much. And that's the whole concept of using agents combined with a RAG tool. This is why it was so important to mention it at the beginning, because we're trying to mix all these concepts that are used by other use cases, but we're using it in this context. So, what does that look like? Let's go directly to the code. I'm going to run it if I have time, but I'm going to just explain to you exactly how this works. That way you have an idea. But this is going to be, this is a project that I'm releasing today as well. It needs some cleaning in the documentation, but the idea is how we can define all these agents in a more structured way. So the first thing we do, we import our libraries. We define our LLM client, because remember, all these agents are going to use an LLM behind it, right, for the reasoning and all of that. Then I define my header. Pretty much, I pass an application with a client secret. This is going to be in my environment variables file. And then we're able to capture the token. And now we can do something as, let's point to the user's Open API specifications. And then we're able to parse all the multiple endpoints that exist in the Microsoft Graph specification. And you can see this is only one example. Like, pretty much think about this as an application that understands the API very well. If you ask me to create an application or a user, I know very specific parameters, but I don't know what else I can do with this API, right? There is a lot of things that we're missing from a security research perspective, in my opinion. And as you can see, the user's API specification has 236 things that you can do with it. And I didn't know about it. All I knew is how to create a user, how to get mail folders from the user endpoints. So that gives you an idea that I'd rather have something that can actually go through hundreds and hundreds of APIs, right? Then I define my agent, and the agent is going to have a persona, because I want to scope a little bit what it is that it can do for me. So if I ask it about the weather, it's going to say, no, I'm a Microsoft Graph API security researcher as well. I don't talk to you about the weather, right? You define the agent, the LLM client, and then you pass the specifications. What this is going to do, it's going to download all the API specs and put them into a vector database in the right format, just to retrieve that information and then be able to execute it. Let's go directly to here. So the first thing that I want to say is test if the RAG tool actually works. So I pass a question, get information about a user with ID X. If I run that, it's going to give me a couple of documents right here. It's going to tell me that these 5 APIs in here can actually be used for my task. And if I look into one of them, is this one right here. If I want to get information about a user, I would use the get user API. But that was in the hundreds of APIs in there. And then even though you might see that there are some APIs that don't make sense, the idea is that this is just one step. The next step is to say, I'm going to take my 5 APIs now, and I'm going to ask the LLM, once again, based on my question, which ones of these 5 are actually related to my question. And remember, language models, especially large language models, they do have a very good understanding, statistical understanding of words in paragraph and text, right? So I would trust this one a little bit better to pick out of 5, to pick the one that I need to execute, okay? We go all the way down, and then I just run the agent right now. And I don't know if you can see this, but the idea is that my agent is going to start executing the concept of get me the APIs. Once you find the API, I want you to, let's just go here, I want you to execute it. And one of my tools is to actually execute APIs, like a very dynamic function. So now you can see that the agent itself, it's already deciding, okay, based on the OpenAPI specs, you need to hit this path, which by the way is a path template, so you need to pass it some type of property or parameter into the path, and the parameter that you need to use is the user ID. All of this done by the LLM, right? And by picking the right APIs from the vector database. I don't know if you guys think it's cool, but it's super cool, right? To be able to just automate this whole process by having the right workflows, right? The right steps to execute it. And then executes it, and then all the way down it says, all right, the information about the user is display name, student01, and so on. So it gives you all the information that it was able to capture when I executed the API, and I pass it a response back to the LLM. Right? And the last thing, which is just the multi-agent example, this is something that I was running right now, and it kind of like failed a little bit, but I'll still explain it, and that's it. And that's the last slide of the presentation. But the tool that I was telling you about, it's a tool that is going to allow us to define agents. And if I go all the way to the actual interesting part in here, we will be able to say, let's define the workflow, let's define the activities that I want to execute, and I can assign those activities to specific agents, and then I will be able to now include multiple agents into my workflow. And right now I'm testing the deterministic workflow, but at the same time we can also make it very autonomous and make one agent decide what to do next. So we're taking the example from before, we're just extending it so that we can cover more APIs. Because I don't want to have one agent with thousands of APIs. I want to have an agent that understands users, understands groups, understands applications, security, right? And be able to collaborate and do everything together. And that tool is going to be released today. So that's the link over there. Its name is Floki because it's a builder. We're trying to make it part of a flow. So Floki kind of makes sense for me. Thank you very much, everyone. I hope you enjoyed this talk and you can use it. So, thank you.